Problem 10. The point P equals 1, 2, 3 is reflected in the xy plane. Then its image Q is rotated 180 degrees about the x-axis to produce R. And finally, R is translated 5 units in the positive y direction to produce S. What are the coordinates of S? So first we start with the point 1, 2, 3. Next, we reflect this point in the xy plane. So what that means is we basically just reflect it to the other side of the xy plane. So that just makes the z coordinate negative. So we get 1, 2, -3. Then it says we rotate 180 degrees about the x-axis. So personally, I don't work a lot with the 3D coordinates, so I like to think about the equivalent of this in 2D. So often in the xy plane, we'll have a point xy, and we will rotate it 100 degrees. And we will get -x, -y. This is basically rotating 100 degrees about the z-axis, if this is the xy plane. But instead, we're rotating 100 degrees about the x-axis. So basically what happens is instead of x, y turning into -x, -y, instead we have y, z turning into -y, -z. So basically our new point is going to be 1, -2, 3. Then we translate 5 units in the positive y direction, so we just add 5 to the y coordinate. So we get 1, 3, 3. And our answer is E. Problem 11. Two non-zero real numbers, a and b, satisfy ab equals a minus b. Which of the following is a possible value of a over b plus b over a minus ab? All the problem tells us is that ab equals a minus b. So we can just find two numbers that work for a and b and plug them into this expression. So for example, we can set a equals 1. So then from this equation here, we get b equals 1 minus b. So 2b equals 1, so b equals half. So now we have two values for a and b, and we can just plug that into this expression. And that gives us 2 plus half minus half, which equals 2. So the answer is E. Problem 12. Let a, m, and c be non-negative integers such that a plus m plus c equals 12. What is the maximum value of AMC plus AM plus MC plus AC? I'll provide two solutions for this problem just because my first solution, I personally think that it's the quickest and it's the way that I solved this problem when I first saw it, but it's not very rigorous, I would say. But let's go with the first solution. So if we just set A equals M equals C equals 4, just to test things out, that satisfies the first condition of A plus M plus C equals 12. And the expression that we get is 64 plus 16 plus 16 plus 16, which is 64 plus 48, which equals 112. And since the problem asks for the maximum value and we have found that the largest answer choice is possible, we know that the answer is E. Now I'll just present a second solution that doesn't rely so heavily on the answer choices you're given. So, first, we want to kind of produce this expression somehow. And we do get that expression if we multiply a plus 1 by m plus 1 and by c plus 1. Because this gives AMC plus AM plus MC plus AC plus A plus M plus C plus 1. We know A plus M plus C is 12, so this here is 13. So basically, we know that AMC plus AM plus MC plus AC equals A plus 1 times M plus 1 times C plus 1 minus 13. So basically, to maximize this, we just want to maximize this. We know that the sum of these three numbers is fixed because that sum is just A plus M plus C plus 3, which is equal to 15. So the sum of these three items is fixed, and we want to maximize their product. And the way we do that is making the numbers as close together as possible. And that's a result of the arithmetic mean, geometric mean theorem, which I won't get into the weeds with, but that's basically the result that we get. So basically, we want these three numbers to be close as possible, and we achieve that by setting A equals M equals C equals 4. So this expression becomes 5 cubed minus 13, which is 125 minus 13, which equals 112. So the answer is again E. Problem 13. One morning, each member of Angela's family drank an 8-ounce mixture of coffee with milk. The amounts of coffee and milk varied from cup to cup, but were never 0. Angela drank a quarter of the total amount of milk and a sixth of the total amount of coffee. How many people are in the family? Okay, again with this problem, I'll present two solutions just because I feel like there's just so many cool ways to do this problem, and I think each way is very cool. So, for the first way, let's define the total amount of coffee within this family as C, the total amount of milk as M, and the number of people as P. So the problem tells us that every person drank 8 ounces, and that's equal to what Angela drank. She drank a fourth of the milk and a sixth of the coffee. So this is what everybody drinks. And there's P people, so M over 4 plus C over 6 times P is the total number of stuff drunk within the entire family. This should equal the total amount of coffee plus the total amount of milk. So multiplying by 12 gets 3MP plus 2CP equals 12C plus 12M. And we can move all the M's to one side and all the C's to one side to get 3M times P minus 4 equals 2C times 6 minus P. Because M and C are both positive numbers, that tells us that P minus 4 and 6 minus P must have the same sign. They must both be positive or both be negative. So we can just plug in these 5 values for P and see if any of those satisfy that requirement. So if P equals 3, we get -1 and 3, which are not the same sign. If P is 4, we get 0 and 2. If P is 5, we get 1 and 1. If P is 6, we get 2 and 0. And if P is 7, we get 3 and -1. Note that if one of the numbers is 0, this equation doesn't work out because we would get 0 on one side of the equation and a non-zero number on the other side, which is not allowed. So the only value of p that makes this problem work is p equals 5, as we said here. So the answer is C. Problem 14. When the mean, median, and mode of the list 10, 2, 5, 2, 4, 2, x are arranged in increasing order, they form a non-constant arithmetic progression. What is the sum of all possible real values of x? First, we can put these numbers in order. So we'll write 2, 2, 2, 4, 5, 10, and x is somewhere in this list. We don't know where. Clearly, the mode is 2 because we already have 3 2's, and no value of x is going to give us a new mode. So the mode is 2. Now, if we consider the possible median values, if x is less than or equal to 2, then the median is going to be 2. Because if x is over here, then clearly this is the median. Next, if x, remember x is an integer, so the next smallest value of x is going to be x equals 3. If x is 3, it would be right here. So the median would actually be 3. And if x was larger than or equal to 4, then x would instead be somewhere over here, in which case the median would always be 4. So we have 3 possible values for the median, and we can just consider those case by case. So for example, if the median is 2, then we have a mode of 2, a median of 2, and a mean. But the problem tells us that these 3 numbers have to form a non-constant arithmetic progression, which is not possible because we have 2 2's. So we don't have any values of x in this case. For our second case, if the median equals 3, then we have a mode of 2, a median of 3. So that means that the mean should be 1 or 4 for us to have an arithmetic progression. Furthermore, as we've already said before, if the median is 3, we have to have x equals 3. So we can go ahead and calculate the mean. We know that in general, the mean should be equal to the sum of these numbers, which is 25, then plus x, then divided by 7. So if x equals 3, the mean is going to be equal to 4, and that works out. So therefore, from this entire case here, we get that x equals 3 is a valid value of x. Our final case is if the median equals 4. In that case, we have a mode of 2, a median of 4. So the mean has to equal 0, 3, or 6 in order for us to have an arithmetic progression. So we can go ahead and set 25 plus x over 7 to equal 3, to equal 0, to equal 3, and to equal 6, and see what values of x we get. So from here, we're going to get x equals negative 25, which we can't have because we said that under this case, x is larger than or equal to 4. Next, we get x equals negative 4, again not possible, and after that we get x equals 17, which is possible because it satisfies the requirements of our case, which is that x is larger than or equal to 4. So we've covered all three cases and we've gotten two values for x, 3 and 17. The problem asks us what is the sum of all possible real values of x. So that sum is 3 plus 17, which equals 20. So the answer is E. 15. Let f be a function for which f of x divided by 3 equals x squared plus x plus 1. Find the sum of all values of z for which f of 3z equals 7. This one's pretty straightforward. We can just set x equals 9z, because what happens is that if we substitute x for 9z in this expression, we get f of 3z equals 81z squared plus 9z plus 1, and the problem tells us that f of 3z is equal to 7. So we can just go ahead and find z. So we have 81z squared plus 9z minus 6 equals 0. Dividing by 3 gets 27z squared plus 3z minus 2 equals 0. But actually the problem only asks us for the sum of all values of z. We can just use Vieta's formulas for that instead of factoring and actually finding the values of z and then adding them. So Vieta gives us that the sum equals negative 3 over 27, which simplifies to negative 1 over 9. So the answer is B. That's the end of the video. Thanks for watching. If you found this helpful, please leave a like, and if you have any questions or feedback, please let me know in my comments and I will get back to you.